Hello all, welcome to my YouTube channel Tech with Gauri. In today's video, we are going to see the working of SR flip-flop, how SR flip-flop works. So here you can able to see the logical diagram of the SR flip-flop. So this is the logical diagram of the SR flip-flop. So you can able to see here logical diagram of the SR flip-flop, and this is the truth table of the SR flip-flop. There are two inputs for the SR flip-flop, S and R, and one of the clock input is there. And output of the SR flip-flops, two outputs are there, Qn and Qn bar. These are called as the present state output. These are called as the present state output. And Qn plus 1 is called as the next state output. Okay. So when we will going to see the working of these flip-flops, actually we don't know about the present state. So in the truth table, if you see, so I have marked that all we don't know conditions, and then we will going to see the next state of the output of the flip-flop, SR flip-flop. Okay. So here in the case 1, we are going to see when both the inputs to the SR flip-flop are equal to 0 and clock is a positive edge triggered. Okay, so that is considered as a 1. So here we are going to see S and R when both the values of the S and R values are equal to the 0. What will be the output of the NAND gate? As if you know the truth table of the NAND gate, here I am going to write down the truth table of the NAND gate. If inputs of the NAND gates are 0, 0, 0, 1, 1, 0 and 1, 1. What will be the output? The output, if any one input of the NAND gate is equal to 0, the output will become the 1 of the NAND gate. Okay. So here we can see S is 0, clock here we are getting 1. So what will be the output for this NAND gate? First, second, third and fourth NAND gate. So first NAND gate output will become 1, because any one input of the NAND gate is equal to 0, output will become 1. For this second NAND gate, output is also equal to the 1, because one input is one input of the NAND gate is 1 and second is the 0. So when these inputs are applied to these outputs of first and second NAND gate will be the input to the third and fourth NAND gate respectively. Okay, and the next input of the third NAND gate is the Qn bar, and here for fourth NAND gate, that is Qn. So 1 into Qn bar. So we will going to see the what will be the output at the Qn plus 1. Okay, so that is the case 1. So S is equal to 0, R is equal to 0 and clock is equal to 1. Okay, so what will be the Qn plus 1? That we will going to find out. So what will be the output of the Qn plus 1? That inputs are 1 into, what will be the equation? 1 into Qn bar and that whole bar, because as you know that equation for the NAND gate that I am going to write down, if two inputs are there, A into B bar. Okay, so these are the 1, A is the 1, B is the Qn bar. So output of the NAND gate will be the 1 into Qn bar whole bar. So this output will become, we will going to see 1 into Qn bar. So output will become Qn bar and double bar. So if that will be the double bar, the output is Qn. Okay, so you can see here Qn plus 1 means next state output is equal to the previous state output, is same as the previous state. Okay, and if you calculate for, or we find out for Qn plus bar, also you will get the same. So we will going to see here again for Qn plus bar, this output of fourth NAND gate. So input for the fourth NAND gates are 1 into Qn and bar. So that will become Qn bar. So you can see the next state output is equal to the previous state output. So here in the truth table, if S is equal to 0, R is equal to 0, output of that next state will be same as the previous state. Okay, so all of you got it. Then we will going to see for the case 2. So what will be the case 2 here? That we will going to see case 2, S is equal to 0, R is equal to 1, and clock of course that is equal to 1. So I am going to erase here inputs. S is 0, only the change in the R input will get changed. So that we will going to write down here. So S is 0, R is equal to 1. So 1 into 1, NAND gate output will become 0. So this output will come over here. So here 0 into 1, that is same as the previous one, 1. And this is also third gate NAND gate input is the output of the first NAND gate. So that is 1. Here input is output of the second NAND gate will be the input of the fourth NAND gate. So case 2, so we will going to see the condition for the case 2, Qn plus 1 for this condition, next state condition. So inputs are same again. So here we will going to see input for the Qn plus 1, that is equal to 1 into Qn bar whole bar. So that is the output of this state. So 1 into Qn bar, that is Qn bar double bar is equal to Qn. So here we don't know the what is the value of the Qn, but we will going to find out this for the Qn plus or a second fourth gate output, that is Qn plus bar. So what is the input for that conditions are 0 and Qn. So 0 into Qn bar will be the output for the fourth NAND gate for next state. So 0 into Qn, of course that is 0 bar, so output will be 1 here in this condition. So output is the 1 means what? Value of the Qn plus bar, next state output is 1. So of course the Qn plus 1 will be equal to 0 because this is the Qn bar, this is the Qn plus 1 bar. So this is Qn plus 1. If this is 1, so output will become 0. So I have written here Qn plus 1 next state output for the condition of S is 0, 1 is R is 1 is equal to 0, and this condition is called as the reset condition. Then we will see for the next third case. Now we will going to see the case 3. Case 3 condition S is equal to 1, R is equal to 0, and clock of course is equal to 1. So for this condition we will going to see what will be the next state output. So here I am going to write down here S is equal to 1, R is equal to 0. If both the inputs are 1, according with the truth table of NAND gate, output will become 0. Here one input is 0, 1 0 means output will become 1. So for third gate one input is 0 comes as it is here, and here for fourth gate this one comes here. So what will be the next state output, that we will see. So Qn plus 1 here, what are the inputs? Third gate 0 and equal to 0 and Qn bar and whole bar. So 0 into Qn bar, that will become 0 bar. So output will become 1. Okay. So if you see that for 1 0 condition, Qn plus 1 next state output you will get 1, and that case condition is called as the set condition. Of course for Qn plus bar, that will become 0. So that we will not going to see here. Then we will go for the next state, or that is called as the next Last state, case 4, when S is equal to 1 and R is equal to 1. So S is equal to 1 and R is equal to 1. This condition we will going to see. So when S is equal to 1, R is equal to 1. When both inputs are 1, output will become 0 for both gates 1 and 2. So here again this 0 comes here, input to the fourth gate, and this 1 comes here, input for the third gate. So if you see for third and fourth, one of the input is 0. So of course the output will become 1 for the both the condition. But this condition is not possible. This condition is not possible. So we will see here Qn plus 1. For this, inputs are 0 into Qn bar whole bar. So 0 Qn bar into 0. So 0 bar will become 1. And for Qn plus 1 bar, also we will see 0 into Qn bar. So both output will be 1. But this condition is not possible. Okay, so this condition for the S case 4, when S is equal to 1 and R is equal to 4. So this condition is not possible. Okay, so this condition is called as the undeterminate state. Indeterminate state. So this state is called as the indeterminate state because this is not possible. Both inputs will become 1. Okay. So here I have written for 1 1. The next state output will become indeterminate ID. Okay. So thank you for watching. I hope all of you have understand the SR flip-flop.